All right. So today's starting problem is brought to you from chapter R3 from one of our students. How do we multiply out or find the product of 2 plus x, that quantity cubed? Find the product. Any idea, Drew?
Give me a second to adjust my eyes.
All right. Ooh, let's do this. Oh, what does this mean? What's the cube mean?
To the third power.
Which means what? What does to the third power mean?
It would be times itself times 3.
Times itself 3 times. So that's what we got to do. Now, it's not the most fun thing, but we can do it. And after we do it, I'm actually going to show you something really fucking cool. It is one of the coolest things. Maybe I should show you later on, you guys' class. We'll just deal with 2 of them right now. Don't go crazy, just do 2 at a time. We do this, I got 2 times 2 is 4. And I got a plus 2x. And then I got another plus 2x. And I got a plus x squared. So if I condense that down, I've got 4 plus 4x plus x squared. And I still need to multiply by 2 plus x. Or x plus 2. I'll leave it in the order it had it though. Now we gotta distribute again. I'm gonna do this way. I'm gonna go with the start of the smaller one and distribute to the left. I'm gonna have 2 times all that, so I'll have 8 plus 8x plus 2x squared. Hey Pedro? And then we'll do the x's. The x just adds an x or increases the exponent. So plus 4x plus 4x squared plus x cubed. All right, let's try to clean this up. Let's write them in descending order. I have one thing that's got an x cubed in it. And I've got a 2x squared and a 4x squared. That adds up to 6x squared. And I have 8x and a 4x, that adds up to 12x. I didn't mean to do double line there, and then we got one constant left, plus 8. So that should be the reduced form of it. Let me find this marvelous thing I want to share with you guys. Actually, I don't need to show you a website. I'll just fucking tell you. I did it for them so they have something to look up. Give you time to finish writing this down, and then we are going to explore Pascal's triangle and binomial expansion. This is one of the coolest things ever. Because you can imagine, like, if this was the 7th power, this would get tedious as hell, right? Check this out. Let me bring up the triangle, or write up a triangle. So this is how Pascal's triangle works. We start with a 1 on top. And the sides of the triangle going down the left and the right have This is the top line. The top line represents the zero. Represents the zero. So I'm just gonna make a little like list over here. This represents 0, 1, 2, 3, 4, 5. I've got 5 listed so far. And these are going to be what we're generating are the coefficients of a plus b to the n power. So the top row will be a plus b to the 0. This will be a plus b to the first power. This will be a plus b to the second power. A plus b cubed. A plus b to the fourth. A plus b to the fifth. Now, this is how we make the rest of the triangle. The top 2 rows are automatically done. What we do for the third row and down is you take the 2 numbers above it and add them together. So 1 plus 1 is 2. You've seen this before, haven't you? Oh, you're okay. You're nodding like this. This is totally old news. And we keep doing this. So 1 plus 2 here gives me a 3 here. And 2 plus 1 here gives me a 3 here. This keeps going on. It's just addition. So these are coefficients, and the triangle can go further as long as you need it to go. Now, how does this work? The first term has a to the n, b to the 0. The second term is a to the n minus 1, b to the first power. The third term is a to the n minus 2, b to the second power. As we go up in terms, the exponent on the first one drops by 1. First term drops by 1. And the second term increases by 1. This is going to go down to the n minus 1 term. That has a to the first, b to the n minus 1. And then the nth term will be a to the 0, b to the n. So I'll write it down in a second for one of these lines. So, do Pascal's triangle. This is fun shit. Yeah. All right, I'm gonna catch you up real quick, Eric, because this is stuff. It's really easy to do. Put ones down the outsides. Then starting on row 3, just add the numbers above it. So like 1 plus 1 gives me a 2 here. 1 plus 2 gives me a 3 here and a 3 here. Yeah. And we keep going down. And then the terms, these are coefficients for terms to something like this, a plus b to the nth power. So if we did a plus b to the 4th power, this is what we would get. I am looking at this row right here. So I'm gonna start off with 1. A to the 4th power, B to the 0. And I'm gonna get rid of B to the 0 in a second. Because anything to the 0 power just equals 1, but it's much easier to recognize the pattern if you just see it with a 0. Then the next coefficient is a 4. The exponent on the A drops by 1, and 1 on the B goes up by 1. And then we got a 6. And the A goes down by 1, and the B goes up by 1. And then we'll do the 4. The A goes down by 1, the B goes up by 1. And finally, we're at the last term where A is to the 0 power, B is to the 4th power. And so we would end up with A to the 4th plus 4A cubed B plus 6A squared B squared plus 4AB cubed plus B to the 4th power. Now we're gonna go back to the problem we just did with the 2 plus x after I give you guys some time to write that down. Did I make a mistake?
I think it's first here.
And maybe I should show what happens when we have A minus B. If it's A minus B. We have all the same values here. But the first one is positive and the second one is negative, and they alternate signs. So on a negative, signs alternate. Let me put this up here with that one. A minus B to the n. Signs alternate starting with a positive. This could massively speed up multiplying out big shit. It only works with 2 terms in each parentheses though. Now, they can be fucked up terms. We'll do the 2 plus x that we just did, and then we'll do something shitty like 2x minus 3y or some shit. It will still work. So the terms go down by 1 for A and they go up by 1 for B. And we just use the coefficients for Pascal's triangle. You can see the first 2 right away. A plus B to the 0 anything to the 0 power is 1. And anything to the first power is just itself, so we got 1a plus 1b. And we see the 1 and then the 2 ones. Just kind of fall out of it. All right. Oh wait, I'm sorry. You're good? Yeah. So let's take a look, I'll leave that triangle where we can see it. We just did 2 plus x by hand. And we saw that 2 plus x by hand gave us x cubed plus 6x squared plus 12x plus 8. And there's a cube on this. Now let's do this with binomial expansion. The cube row is the one that has the 3's as the second number. Notice that the like if I filled this in with like a 0 here. This diagonal, the second row, is n. It shows what n is. It's always equal to n. Which is pretty handy. So even if you got a big triangle, you can quickly check to see what row is which. Which tells me if we're doing a cube, I should have a 1, then a 3. I'm doing the 1, 3, 3, 1 row. That's what it's telling me right now. So this is my A and this is my B. So I start off with A to the max power, B to the 0, and I'll fill in what I have in a second. 3a squared b to the first power plus 3ab squared plus b cubed with a 1. Now, oh, that has a to the 0 there, right? A to the 0. So that goes to 0, or 1, sorry, 1. And that goes to 1. So my first term is a cubed, which is 2 cubed. And then I have 3a squared, which is 2 squared, and then b, which is x. And then I have 3, I have a to the first power, which is just 2, and the b, I have an x, and it gets squared. And finally, I have just the b, which is the x, and it gets cubed. I'm deliberately making sure I do parentheses on everything, even though if it's quicker if I don't. Because as soon as we have something like 2x or 3y in here, everything needs to get hit by the x value. So 2 cubed is 8. This is 3 times 4 times x. So we got 8 plus 12x. And then 3 times 2 is 6. So 6x squared. And then plus x cubed. And if I rewrite them in descending order, I get the coefficients we calculated earlier. Now, doing this doesn't save a lot of time for the lower level ones. Where n is small. Squared, you probably quicker just doing it. Cubed, it can help, especially if we have something fucked out like the next thing. Let's take a look at 3x minus 2y cubed. Wait, maybe we shouldn't go cubed. Let's go to the 4th power. Okay, so looking at my triangle, the row that has the 4 in it, I have the coefficients 1, 4, 6, 4, and 1. The negative tells me the signs alternate. The first one's positive, the second one's negative. That, so I should have signs like that, or I should have numbers like that. So I start off with a to the 4th power. This will be my a, this will be my b. I have a to the 4th, b to the 0, minus 4, a cubed b to the 1st, plus 6, a squared b squared, minus 4, a b cubed, plus b to the 4th. That's without dealing with the 3x or 2y, negative 2y yet. Well, we dealt with the negative part. So in this setup, a equals 3x and b equals 2y. Not negative 2y. We already dealt with the negative by changing the signs. All right, let's plug this nastiness in. A to the 4th power is 3x to the 4th power. And I have minus 4, A cubed is the 3x, that thing cubed, and B is 2y. Then I got 6, and I have 3x squared and 2y squared. And I've got -4, 3x, and then 2y cubed. And then plus 2y to the 4th power. You don't have to remember that the minus does an alternating thing if you plug in the minus with the b. If you put the, if you use -2y, it's going to fall out. Negatives, the signs will alternate. Like this would be a positive right here, but 2y would be a negative. Over here, this would be a positive, but -2y cubed, we have 3 of them. The negative, 3 negatives is going to be a negative again. The ones that are here with the even numbers, the negatives with an even exponent go away. So they're still positive. All right, now I didn't say this was going to be super quick, but it's definitely quicker than doing this by the long way out. So 3 to the 4th is like 3 squared times 3 squared. '81. So this one is 81x to the 4th. This is going to be -4 times 3 cubed, which is 27, times 2. And I have an x cubed y. And I'll clean up that calculation in it. We'll do that in a second. This one, we got 6 times 3 squared is 9, times 2 squared is 4. And we got an x squared and a y squared. So I'm just doing all the numbers first and then the variables. -4 times 3 times 2 cubed is 8. And we have xy cubed. So maybe I'll write underneath it where it came from. This is 3 to the 4th. That's 3 cubed. 3 squared and 2 squared. And then 2 cubed. Finally, we have 2 to the 4th over here. That's going to give us a 16. Okay, 4 times 27 is like 4 times 25 plus 4 times 2, which is 108. And then we double that, that's 216. So we should have 81x to the 4th minus 216x cubed y. Ah, fuck. 9 times 6 is 54. Is this another 216? It might be. Yeah. 216 x squared y squared, that's convenient. This is 24 times 4 is 96. That's the glory of Pascal's triangle. Now, not quick work, but this was never going to be quick work. And yeah, the other option of doing this was doing 3x minus 2y 3x minus 2y, 3x minus 2y, 3x minus 2y. So this is gonna get ugly no matter what. There's a lot of shit going on, right? But the pattern was simple. Before I plugged in the 3x and the 2y, the pattern isn't bad. We just have the coefficients from the Pascal's triangle, which was just doing addition. That's all we did was add basic numbers together to get those things. And then one of the exponents goes down and one of the exponents goes up. Not bad.
Even when it's like an even number, you could just do it.
Yeah, I think this, if I did this by hand, I would work out 3x minus 2y, I'd have 9x squared. I would have plus 4y squared. And I would have negative 6xy, there's two of them, negative 12xy. And I would do that, that's one set of two. And then I would do the same thing and do it like that. If I were to multiply that by hand.
When it's like that, it's not as bad.
It's not as bad, the odd number is gonna really throw it off. And when this is like to the 6th power, this is now a clusterfuck. You know what I mean? Alright, some other stuff we did on. Oh shit, it's been like a week, hasn't it? You guys missed me, didn't you? Started to twitch, right? Twitch,
Make a weekly dose of epic.
that's right, you do. It's supposed to have 2 doses. And you got cheated. So we were working on R4 and that was on factoring. So let's take a look at factoring. Let's try to factor, and I'll let you guys try before I jump in. 2a squared plus 3ab squared minus 6b cubed minus 4ab. Make sure everybody's on the same page. What do we do when there's four of them? We do it by grouping, yeah. So try to pair them up. See what you can factor out. You have an idea? Oh, I fucked you guys up with having A's and B's in there, didn't I? Yeah, I did, yeah. This is how Homer does it. Homer makes this shit fucking hard.
Wait, is that -6b or 66?
Minus 6b cubed. 66 cubed would be, that's fucking ugly.
Yeah, that's why I thought it was 66 cubed.
Let me write these as capital B's.
Scared me for a second. What do you mean 66 cubed?
And these are capital A's. Let's make these capital A's. My A's look like nines, it's fucking lame. Alright, so. What comes out of the first set? Not a lot, right? Just an A. What do I have left over? Squared. Right? Now. What do I have over here? What comes out over here? The 2b. And they're both negative, so I'm gonna take out a negative 2b. That'll leave me at 3b squared. And dividing out the 2 from the 4 and the negative, we'll make that positive 2. And then we've got an A, and then the B gets taken out. Well, that's the same thing, right? If I switch the order, this is 2a plus 3b squared. So we have matching parentheses. We can factor that out. And whatever's left over goes in another parentheses. You know. Common Buzz doing this, and a lot of teachers like doing this. But I've done a lot of end game shit in physics and stuff like that. And I don't remember ever having anything fucking convoluted like this. You know what I mean? Now, I've had multiple variables in there before. But usually at that point, if there's just so much shit going on, you're letting the computer do it.
Yes.
You want another one? Let's do 6x² minus 11x plus 3. 8 times 3, and we got our B. So it needs to multiply to 18. Add to -11. Now, if it multiplies to a positive number, they're either both positive or they're both negative. And if they add to a negative number, at least one of them's gotta be negative. So in this case, it means they're both negative. So let's just try -1, -18. -2 and -9. Oh, there we go. We're already at it. You missed some good shit. Pascal's triangle. Yeah. We just multiplied out, what do we do? 3x minus 2y to the 4th power, super quick. Alright, so that's the right connection, which means this can separate into -2x and -9x. And we'll bring our 6x squared and our 3 down. Alright, so we do grouping again. It's like a 2x comes out of this, and we're left with 3x minus a 1. And it should have another 3x minus 1 here. Which means to get a 3x minus 1, I can see I need to factor out a 3, but to get the right parentheses, I need to factor out a -3. Finally, we end up with 3x minus 1 and 2x minus 3. Stop recording for that one.